Theme 3, Session 4. We're talking about men and stones. Beyond the obvious fact that both man and stone are comprised of matter, they do not really have much more in common. A principal distinction between them is that a stone does not have volition. A stone cannot exercise choices. A stone cannot determine where it will land. Once in motion, the stone cannot alter its own course. But a man does have volition. A man can exercise courses. A man can determine his course of action or not action. You can predict accurately and consistently the course that a stone in motion will follow, but what you cannot predict accurately and consistently is the course of action that a man will follow. For example, where are you going to be on January 1st, 4 p.m. in the afternoon of, 2037? Where are you going to be? In a bar, in your car, walking in the garden? Where are you going to be tomorrow at 4 p.m.? That's easier, right? You have a doctor appointment. You will be at the doctor's office. You may have a doctor appointment at 4 p.m., but does that necessarily mean you will be at the doctor appointment at 4? No. Your automobile might break down on the route to the office. You might change your mind at the last minute. The doctor may have canceled the appointment because he is sick. You can get lost on the way. You could get stuck in the traffic, or any number of other things can determine that you cannot be there at 4. But if you cannot predict your own future, Voland said that once, how could someone else, some external observer, predict it for you? Therefore, there is a very important distinction between the science of physics and the science of volition. Physics explains the nature of non-volitional phenomenon, non-volitional. The science of volition explains the nature of volitional, animate phenomenon. Physics is a relatively simple subject due to the fact that in physics it is much easier to observe accurately causes and effect relationship. For example, in physics you are not concerned with a question such as, well, I wonder if it's proper for the planet Earth to revolve around a star called the Sun. Or, I wonder if it is moral for the Earth to move in an elliptical orbit around the Sun. You see, it's enough in physics that you can prove that the Earth moves in elliptical orbit, whether this is moral, or proper, or even a factor of consideration, because morality, proper conduct, ethics, these are not subjects that are dealt with in the physical domain. In other words, in physics, we are not concerned about ethics, morality, so forth, but in volition we are. Physics is an amoral subject, not immoral, not to confuse. Immoral means not moral. Amoral means morality doesn't apply. Physics are amoral. Now, how you apply the concept of absolute rightness to volition? There has been those who have tried this, even those in the physical sciences have attempted to apply their knowledge of the physical sciences to volition. For example, a physicist might begin in the following way. He might say, you will find the most of your thinking verbalized. If your native tongue is English, you will likely think in English language. Your thinking is verbalized. There's vocalized, some vocalized. Not all of your thinking has to be vocalized, but for example, if your field of physics and mathematics, physics or mathematics, you may think in terms of equations, but even behind these basic fundamental terms, equations and so forth, are still some basic verbalization. You can see an equal sign and your mind says equal or not equal or less than or greater than and so forth. And we have specific terms that represent those concepts in mathematics and science. All right, if we think with language, what happens if our semantics, the various terms we use, what if our semantics are muddled, confused, imprecise? What can we say about a person who thinks in such terms? In a like manner, so his, her, our thinking we muddled, confused, imprecise. And that, ladies and gentlemen, is why most people have muddled, confusion, and imprecise thinking. Because the terms that most of us use, the language most of us use is imprecise. There is no precision if somebody doesn't understand what I mean by imprecise. I'll be illustrating, especially today and next week, without semantic precision, you cannot have precision thinking. And there's no exception. No exception. And that applies to both classes, those who went to school and those who did not. No exception. Our cliches, you should watch out for. A common one, you ask someone, define your term, sir, or ma'am, and commonly you'll get back, well, that's only semantics. You've heard this cliche. That's only semantics. Anyone who uses this cliche has immediately admitted he doesn't know what he is talking about. Because if he knew what he is talking about, he would define his terms. And the cliche, that's only semantics, is a defense mechanism. He doesn't want to admit that he's been exploited, and he doesn't now want to admit he has no idea what he's talking about. Remember that definitions in science are always arbitrary. That simply means somewhere, sometime, someone coined the definition. A definition is defined in order that the one coining the definition can communicate. And the only time you should ever use somebody else's definition is if you think it's useful. And this is how you can avoid so-called hang-ups on definitions. If an individual, for example, doesn't like a given definition, then he can define the term to his liking. But if two parties cannot agree upon a particular definition, if they both define their terms, both of them, even though they disagree, they still can communicate, you understand? If they explain that to each other. If you don't like Isaac Newton's definition of force, the same definition of force that built this tape recorder that enables us to go to the moon, if you don't like Newton's definition of force, then define it your own way. Fine, but then you might also ask yourself this. Will your definition of force build tape recorders? Will you get, with your definition of force, to the moon? Etc., etc., and again, etc. Another difficulty we have with communication is that too many people own dictionaries. I'm sorry. I won't ask for a show of hands. I'm sure many of you own a dictionary. And there is a great catastrophe. Great catastrophe. Really, I'm not joking. Most people do not understand the principal function of a dictionary, and that leads to great problems. What is the principal function of dictionary? You know what most people believe? That the purpose of a dictionary is to define words. This is a major intellectual blunder. Major. What is the principal function of a dictionary? To record something. What? To record common usage of a language. Not more than not less. Common usage of a language. What happened if someone will look up some particular term in the dictionary, perhaps even an unabridged dictionary, and they will read the definition. This is the definition, and there is a bolt of lightning and a clap of thunder, and it's etched in stone. It says right here, that ends all argument on the subject. Here's the definition, right here. No, ladies and gentlemen, no. The purpose of a dictionary is to record usage. If it happened to be, for example, a great, big, fat dictionary, like an unabridged dictionary, in addition to recording the common usage, it may also record the uncommon usage, which might be an archaic usage. This is what the term meant in Elizabethan England. Or the esoteric usage. This is what it means in biology. This is what it means in art. This is what it means in geology. Esoteric, in other words, implying particular to a specific domain of knowledge, not generally known to public, outside of the field. This is esoteric. Secondary functions of a dictionary might be to standardize pronunciation, spelling, and so forth, but its principal function is record common usage and then uncommon usage in that order. Other problems that the dictionary impose. This is a frightful one, and I'm sure you have all encountered. You look up a term in the dictionary, you carefully read the definition, and then you notice there are several terms in the definition that you'd like to look up. So it occurs to you, well, let's look up those terms and find out what they might mean. Invariably, you look those terms up and guess what happens. The very term you first look up now pops in the definition of the second word you looked up, and you're right back where you started from. There is a name for this. It's called circulary. You just keep going around and around and around. Essentially, a dictionary is a study of circularity and imprecision. In science, ladies and gentlemen, we actually have no room for synonyms. If you have a science, you cannot afford changing definitions. To be a useful one, it must be one, single, unique. There's a term people sloppily used. Unique comes from uni, meaning one only, no other. Just one, unique, single, lone, precise meaning. That's what a definition in science should look like. And here's what it does look like from a graphic standpoint. You drew a very sharp line of demarcation around the territory which is being defined by the term, and you separate it from what? Everything else in the entire universe. So that it has one single, lone, unique meaning. In addition, of course, the definition should be true or fit reality. It should be useful and consistent part of the total structure of the science. We'll talk about it next time.